You know, we are surrounded by computers every single day. They're in our pockets, on our desks, even in our cars. But have you ever really stopped to think about what a computer actually is? Well, today we're going to pull back the curtain on this incredible machine. We're going to trace its journey from a really surprising origin all the way to the invisible tech that pretty much runs our world. So let's just dive right in at the very beginning. So let me just ask you a question to get started. What do you think the very first computer was? I bet you're picturing something, massive, a room-sized machine from the 1940s with all the spinning tapes and the flashy lights, right? Well, the real answer is probably not what you think. Get this. The first computers were people. Yup, that's right. The word computer, first written down way back in 1613, was a job title. It was for a person, a human being, whose entire job was just to do math all day. For centuries, that was the definition, long before a single circuit or wire was ever involved. Kind of wild, right? Okay, so if the definition has changed that much, it's a fair question to ask what a computer even is anymore. Well, it turns out, whether we're talking about a person from the 1600s or the smartphone in your hand right now, every single computer follows the exact same timeless, fundamental formula. It all boils down to these four core functions. People sometimes call it the IPOS cycle. First, you've got input. That's just getting data into the system. Think keyboard, mouse, microphone. Next up is processing. This is where the brain, the CPU, does its thing. It crunches the numbers and follows all the instructions. Then, of course, you get the output. The results pop up on your screen or out of your speakers. And finally, you have storage, which is just saving all that information for later. That's it. That's the blueprint for every computer, ever. So, how did we make the jump from a human doing math to a machine that could follow that cycle all by itself? Well, it didn't start with electronics. It started with gears and levers and a couple of brilliant dreamers who were thinking a solid 100 years ahead of their time. Meet Charles Babbage. Back in 1837, he designed something called the analytical engine. Now, the crazy thing is, this machine was never actually built in his lifetime. But the design was pure genius. It had a processor, he called it the mill, and it had memory, which he called the store. But here's the kicker. It could be programmed using punched cards. This was the first real blueprint for a general-purpose programmable computer. And this is where the story gets even better, because Ada Lovelace enters the picture. She didn't just get what Babbage was doing. She saw its true, world-changing potential. She wrote what we now recognize as the world's first ever computer program, an algorithm designed to run on this theoretical machine. And even more than that, she imagined that a machine like this could one day do more than just math. It could compose music, create art. She saw its creative potential. She was, without a doubt, the first true computing visionary. Babbage's mechanical dream, though, was just too complex for the technology of the 1800s. It would take about another century and a full-blown electronic revolution to actually make it happen. And this revolution was driven by one simple, relentless mantra: make it smaller, make it faster, and make it cheaper. You can really see this progress when you look at the generations of computing. The first generation, back in the 40s, ran on these big, hot, clumsy vacuum tubes. Then, the second generation, in the 50s, was powered by the much smaller, much more reliable transistor. And the third generation, in the 60s, crammed those transistors onto tiny little silicon chips called integrated circuits. Each step was a massive, massive leap. To really get a sense of the scale of this change, just look at the ENIAC from 1946. This thing was a monster. It filled a huge room, used over 17,000 vacuum tubes, and was famous for breaking down because those tubes were constantly burning out. Programming it meant spending days, literally days, unplugging and replugging cables by hand. And then, in 1947, the invention that changed everything showed up: the transistor. This one little device replaced those big, fragile, power-hungry vacuum tubes with a tiny, solid switch. And just like that, computers became dramatically smaller, way more reliable, and so much more energy efficient. This was the moment that made computing practical for more than just giant secret government projects. And that piece of change, it didn't just continue, it accelerated like crazy. The whole thing could really be summed up with this simple, powerful idea: a doubling, a constant doubling of power. This is, of course, Moore's Law. Back in 1965, Intel co-founder Gordon Moore noticed that the number of transistors we could cram onto a chip was doubling roughly every 2 years. Now, the important part isn't just that he predicted it, it's that this observation became a self-fulfilling prophecy. It became the target, the driving force for the entire industry for decades, giving us this incredible exponential growth in computing power.
So, this exponential growth, this engine of Moore's law, is what finally took the computer out of the high-tech lab and put it into our homes and onto our desks. This next phase was all about making the computer personal.
The key invention that unlocked all of this was the microprocessor, an entire CPU, the whole brain, on one single tiny chip. That was the breakthrough that made personal computers affordable for the first time. All of a sudden, you could have hobbyist machines like the Altair 8800 and then user-friendly computers like the Apple II, and just like that, the personal computing revolution was on. But, just having a computer wasn't enough. You had to actually be able to use the thing. Early computers had what's called a command line interface. You had to type in these weird, cryptic commands just to get it to do anything. The next giant leap forward fixed this problem, and it was called the Graphical User Interface, or the GUI. With icons, windows, and a little mouse pointer, the GUI made computers intuitive. It made them accessible to absolutely everyone, not just the programmers and the geeks. So now we've got personal computers that are actually easy to use. What could possibly be next? Well, the next great leap wasn't really about the computer itself. It was about connecting all of them together, which brings us to the world we all live in today. The internet, what can you say? It completely transformed these powerful but lonely machines into one giant global ecosystem. It gave us instant access to basically all human knowledge, it created brand new industries out of thin air, and it totally changed how we talk to each other, how we shop, how we entertain ourselves. The computer wasn't just a tool for work anymore, it became our window to the entire world. And that brings us right up to today, to this idea of ubiquitous computing. The goal isn't just to make the computer smaller anymore, it's to make it invisible. The idea is to weave computation into the world all around us, into our watches, our speakers, our homes, so that the technology itself just fades into the background, seamlessly helping us out with our lives. So think about that journey. We went from a computer being a person's job title, to a machine the size of a room, to a device in our pocket, and now to an almost invisible force woven into the very fabric of our world. And that leaves us with one last big question to chew on. As computing continues to dissolve into our environment, how does that change our relationship with technology? And maybe more importantly, how does it change our relationship with each other?